Hey, this is Dr. Graves with a quick video tutorial that will help you get through some of the basic measures of central tendency and dispersion around the mean. We'll take a look at this in ArcMap, or I should say ArcGIS Pro, and then repeat the calculations in Excel. So here are the two homeworks that are associated, the two assignments associated with it for Geography 460 in class, assignment data and central tendency 1, and then the take-home version where you basically will have to repeat what we do, what I show you for the in-class assignment on the U.S. states, but you will have to repeat it with the California data. So let's go ahead and get started. Here is the Intro to Descriptive Lab 1, the base map that you'll be working with. This is the U.S. states, and basically what I'm asking you to do for this assignment is to just a couple of things here. First, we're going to open the attribute table. So I right-clicked on U.S. states and open the attribute table. And I believe in this that I've asked you to bring up some of the statistics for various columns of data here. And so population 2000, I right-clicked on that, and I am selecting statistics from the pop-up window or the drop-down menu, whatever you like to call it. And there you go. It gives you a histogram in the window where the attribute table was, and over on the right side it shows you some of the basic statistics, including the mean. And if we select, there's now the median. Because the median is to the left of the mean, that means that there's some skewness to the right. We see that it gives us a positive value for skewness in there, and we can grab the standard deviation. Now this is an odd standard deviation because it only presents a bar on this side of the mean and not one on the other, which gives you some indication of the amount of skewness. This histogram does not resemble a normal bell curve in any sense, and that's because California, which is over here, if you select it here or in the map, then it appears. It likewise will appear in the attribute table at the same time. California is skewing the data pretty badly, and it doesn't help that Texas, New York, and Florida also contribute to the skewing of how you bring up. We'll just do it for something like clear the selection and right-click on population per square mile and bring up statistics once again. Wildly skewed because of Washington, D.C. is included in there. So that is a massive outlier, and it's really changing the way the data is collected. So what you would do is switch selection. Now everything else is selected, and then here we need to look at the statistics for just the selection. So we see now that it's only 50 states. We can bring up once again the median and the standard deviation, but the skewness has dramatically decreased from 6.6 to 2.03 because we've excluded Washington, D.C., which is not really a state anyway. So that's how you do that part. That should get you started on that. I'm going to clear the selection once again, and I'm going to get rid of the U.S. states map itself, or the attribute table, I'm sorry. And let's go through some of the types of mapping that we can do with the data, very basic stuff. So we're going to do right click and select Symbology, which is on Arc Pro in a different place, and we can draw or make our maps using several different symbolization strategies, because if we wanted to map the states using nominal, text, or string variables, we would use unique values. I'm going to select that, and the field that we'll be using is state name. It's a name, it's nominal data, so I click on that, and then it gives us this very absurdly colorful map. And everything's pretty cool, except I don't like it when the two states of the same color touch each other. So maybe you want to, double click on Arizona and give it some other color that's not touching it, and some obnoxious purple sort of thing would do it. It's sort of out of character now, but it doesn't touch any of the other states of the similar color. So that's how you would symbolize nominal data. If I go back here, you can change the color scheme to something a little less grading, like these pastel colors. I think that looks a great deal better. So that's nominal data, and that's how you would properly map this. It's not a choropleth map, but a choroclass map. So it's a classification not by numbers but by names, words. This works for state names. It would also work for some of the other things in here, including the FIPS code. The FIPS code appears to be a numeric value, but it indeed is a string or nominal variable. It's very important to remember that FIPS codes and zip codes are nominal. So let's switch and change the primary symbology from a nominal data to a graduated color map. And there's something we could use is the sort of standard here. Object ID doesn't make sense, but population per square mile would. And population, basically all of these variables. So population in 2000, let's use that. And there's natural breaks, and that looks reasonably good. And that works for many of the things that you want to do. But I believe if you're, for scientific purposes, that you should use either quantile or equal interval, or set the interval manually, so it's sort of a fair thing. So let's take a look at quantile. Now we know that California has population that is far greater than any of the other states, almost double Texas or New York. So it's really in a class all by itself. But what this does is it sort of hides that a little bit and takes the 50 states basically and makes 5 categories out of them, so that there are 10 states basically in every single category. And you will have to decide whether you think this is a fair classification system or a not fair classification system. Does it hide more than it reveals, is the question that you need to ask yourself. If we switch to equal interval, what that does is takes the range of the data from the smallest state, which is probably Wyoming at about 450,000 people, down here, here somewhere, it's well, that's the upper value. So Wyoming, if we click on that, is the population is at about 500,000, which is a suburb in California has that many people. And so it takes that as the bottom of the range, and it takes the California's population in 2000, which was probably 33 million, and that becomes the range, the smallest to the largest, and it divides that into 5 equal categories. California, because its population is so vastly larger than any other state, it is by itself in a class by itself. Texas likewise is in a class by itself based on this classification system, and then New York and Florida are in a class among themselves, and then Michigan, Illinois, Pennsylvania, Ohio, Virginia, and Jersey and Georgia are in a class by themselves, and then everybody else is in the class at the bottom, which, this class has an upper value of, nearly, is 1 million people, something like that. And you can look at this sort of histogram here and where the average is, and you can take these and play with them a little bit, but this is not, you're starting to do things with it that perhaps you don't really want to do. Then, of course, the me just changing that a little bit, changed it to manual interval. Frequently, what we might want to do here, if I go back to classes, is to double-click in here and put something that is round, say 1 million. Anything under 1 million is the upper category, and then we could maybe make this 2 million. I don't know, 5 million, and so on. And so I've reclassified these, somehow managed to actually take out an interval accidentally, but then this is a manual approach, and this may be worth your time as well. All right, so then the last of these steps that I was going to show you was how to export data from the GIS environment over into Excel. Certainly there are a lot of things that the new version of Excel will do in terms of infographics and bringing up various types of statistics, but there's a great deal that it won't yet do, or it won't do in a way that gives you full control. So we want to be able to export this data, and there's several ways of doing it. You can open the attribute table, and from here I believe there's an export function. You can right click here and go to data and export the table, and that's yet another function. So whatever way that you find great, do that. I'm clicking export table. It's asking for the parameters. Don't put it in a geodatabase because you won't be able to get out of there. And so what you want to do is just put it somewhere where you can find it. I'm going to stick it on my desktop, and or I don't know, I'll just stick it in Zoom, ArcGIS, and then give it a name, US State Data. And I believe I click OK, and it saved it as a DBF, and I'm going to go find that. So that's the end of this tutorial. I'll have another one about what to do with it in Excel once we reopen.